Hi, this is Mustafa. I'm capturing this video to show you pretty fast like what Honeybee does. This is basically a video for the first release of Honeybee. I'm personally so excited about it. So with Honeybee, we will release a new version of Ladybug. It's almost the same, but you have four new components here, developed by Chris and Siron. Hopefully, I'm pronouncing his name right. Make sure to check these things out. For Honeybee, just like a quick overview, you get five different tabs. One is missing for energy simulation, will be added soon. And this one is for developers. So the first one gives you the options to generate the geometries. Like there are several options. You can prepare the geometry in different ways. You have a full set to create materials, edit materials, check the materials, add them to library, all that stuff. A tab for skies, so you can generate different types of skies, climate based, standard skies, sky based on a value, and you can watch it. I will show you an example. And then you can run different types of analysis, which I call it recipe here. Like you can run annual analysis, daylight factor. You can do a grid-based simulation, image-based, vertical sky component. You can set up the parameters. You can even run advanced dynamic shading using DaySim from Honeybee. Oh, I forget to say. So Honeybee is basically, if you don't know what is Honeybee, I just assumed everybody knows. Honeybee is an environmental plugin for Grasshopper that makes you able to run daylighting analysis for now. Energy analysis is underway, is coming. For now, it is like the current release has the connection to Radiance and DaySim. You need to download and install Radiance and DaySim. You need to download and install Eval Glare. Like in a release note, I provided the links and I actually wrote why you have to go download it yourself. I don't want to do a single click install for you. Here is you can see you can run the analysis. You have different kinds of visualization that I will show. Uh, Converting the HDR image and run glare analysis. So okay, like I will show seven different example files that basically shows what you can do. So the first one is showing you the skies. So you can generate different types of skies. In this file, I'm generating like all the standard sky possible, and I use the watch the sky to generate these images. And you can see different types of sky. So for example, now this is a cloudy sky, right? So you know why daylight factor doesn't consider the orientation in calculation because basically all the sky looks the same in all the orientations. This is a sunny sky. You can generate climate-based sky, and for all this sky, watch the sky component give you the global horizontal irradiance value. Here I am doing a comparison between the data generated by the sky and the ones coming from the weather file, and as you see, they're pretty close. Oops, sorry. uh, okay. So next one, let's see this one. The simplest thing that you can do is basically generate the material, assign it to the geometry, define the sky, and generate a physically accurate rendering as I did here. If I can tap, I can't. Okay, here. If you do multiple renderings, you will get the shadow analysis. So what happens here, because you can define the sky parametrically, so you can define the sky, you can generate the sky for different hours of a day, right? So you only need to animate this slider to generate all the skies and then render them all together, and then you can put them together and it will generate something like this. I mean, you can change the view definitely in any ways that you want. So this one was 03, 04. I can't see 04. Probably you all can see it in okay, here. 04 is you can run any grid-based analysis. In the examples I didn't show you in Rhino. So here what you can do, this is a room. In this example, what I put together is you can set it up like so. Here I'm running it for 5 different percentage of the glazings, as you see, and 5 different glazing type from 40% to 80%. You can generate the material parametrically. You can generate the geometry parametrically too. Here you see like the way I'm generating the geometry is different from the other files, which was like face by face. So you have a mass. You can check it out yourself. So when I'm done with the video analysis, here I can go and read the result back, and then start looking around and say, okay, this is the effect of changing the glazing percentage, or with the same percentage, the change of transmittance of the glass, change the material type, and it will generate the result. I'm using Ladybug components to actually generate the mesh and all that stuff. And one thing I want to add is all the result, I'm actually reading it from the files, and it doesn't come from the components. And it's important because when you run a simulation once, as far as you have the folder, you can always recreate that scene in Grasshopper for presentation, checking out the result, regenerating some stuff when client comes back in like 2 months. You know what I'm talking about. Mm, then you can run glare analysis. This is the same example that I ran the shadow analysis for. So now I just considered you want to design a building here, and for glare analysis you need to produce a fisheye image and luminance. This is a false color, but like I just wanted to show you. And there is a glare component that lets you run the glare analysis. I put the number here for the DGP daylight glare probability, so later if you come back the image has the number on top of it. I tried to put all the notes, so I'm not going to talk about that. So it's just like in a way that I tried to put it in a way more than just an example file. So when you're playing around with the definition, you have to kind of think about why are you doing what. And last but not definitely the least is the annual simulation that you can run. So you can run annual simulation with Dasim. I put an example file here, and the list that you can do is generating the results that are typical for annual simulation, is like, okay, getting the useful daylight autonomy, spatial daylight autonomy, annual profiles, all this stuff. But I personally think like the annual result has so much more potential than only getting a number for a year or something. One of the things that I really like is this one that actually not this one, this is the other is this one, that you can read the results back from the annual data and animate it for every single hour of the year. So basically you run the analysis once, and then you can always go back and check the result, because especially for design cases you want to go back and see, yes, okay, daylight autonomy is this number, but why this is this number, when this thing is happening, which building is causing the problem. And for the ones who want to run more advanced analysis, and like especially who are daylighting designers or something, there is another feature here. Not only you can get the result for every hour of the year, for any point of your sensor points. For here I selected this tree. You can get the result for the whole year for that point. So this component, you connect these points and it will show me the result for the whole year for that 3 point. Let me go to the top view. Here you go. So you see, like for example, they get the light in the morning, in the afternoon they don't. So if you want to see where do you want to put the sensor, or if you want to do a comparison, right now I selected 3 points which are basically in the same place. But if you select 3 points in three different places and just connect them here, you will see a better result. And I think it's really helpful to compare and just make decisions where to put the sensors and all the stuff. Oh, and something that I try to address, this is for advanced users, but they seem by default how they designed it is only for a single space. So if you're running something like this and then you want to get the profiles, like the lighting profiles, like everything, like all the calculations, so you have to run it 3 times really if you want to run it. But I tried to use the data management in Grasshopper, and every single branch is basically a different space, so I just recreate the heading files, all the stuff. So as you see, you just pass it once and it gives you the result for, you can't see because I disconnected that, but it gives the result for three different spaces. That's why you get three different batch files. And something interesting that I forgot to say is to make the analysis faster, you have an input for number of CPUs. So if you have a good computer, I have only four, just like, but I put it to 24 here. But if you have 24 CPUs, then that's awesome. So instead of using one CPU, it will use 24 CPUs, so it will be way faster, especially for annual analysis that can take forever. And finally is again annual simulations, but you can even define dynamic shadings, and you can get the results of the dynamic shading out there here using the similar uh, components that I showed, so you can map it out. Again, this is something for really advanced users, but something really interesting that can come out of it is like where I put all this stuff together, and for each hour of the year, let me for each hour of the year, I can zoom in a little bit. F7. For each hour of the year, I can go and read the result, and here what you can see is what's happening without having the blinds, what's happening with having the blinds down, and what they seem selected. So you can have a really good understanding of what's happening in your building, and when they seem thinks that blind should be down, when it thinks the blind should be up, why it's making these decisions, because you can see where you put your sensors that causes this result. So here I put the sensor in the here and here. Definitely this one doesn't make that much of sense, but I did it because I wanted to ask you, does it make sense to put the sensors there? I gave you the answer right now. But you can do that. You can go here and basically plot all the annual profiles for shadings, for lighting control, for the occupancy. And this is, I think, the last thing I want to show. Hopefully this video. So here you can see this is the occupancy profile. Let me maximize this. That shows when people are here, and you see they're out for lunch. This is the daylight saving time, and this is the shading. So whenever it's blue, it means the shading is closed. Whenever it's not blue, it means it's open. And like you can go back and forth between all this data that you have and make good decisions for your design. Okay, that's it, I think. And for the ones who don't know what is Ladybug, and what is Honeybee, Ladybug and Honeybee are two open source and free plugins. I started the development, but now we are more than one developers. Uh, it lets you running like mainly Ladybug was for weather data analysis and simplified environmental simulation. Now you get Honeybee, which is for my advanced simulations that I just showed. We have a Facebook page where I actually send like update all the stuff that's happening to be more in connection with the development, because on the Grasshopper page is the best place to send your questions, discussions. Other people are watching, they can answer to your questions, all that stuff. You can check the GitHub repositories. Uh, the code is everything is here. The source code is here. You can check it out. User objects are there too. We are commit like we push all the development to Honeybee. Here, there will be always an unstable version here if you want to play with. And if you're not a Facebook person, you can follow Ladybug on Twitter to be like keep yourself updated about the development. Uh, Thank you for the great comments and suggestions, and just keep them coming. And sorry, not the energy simulation components are there. There will be theirs pretty soon. Thanks again.